Show that the function p of x equals x to the fourth minus 5x plus 3 has a root in the open interval 1 to 2. So to say that this polynomial here, p of x, has a root means that there is a number x where the polynomial is equal to 0. A root means equal to 0. We're trying to find where the polynomial crosses the x-axis. Those are called the roots of the polynomial. Okay, well, our function p of x is continuous. It's continuous on the interval minus infinity to infinity. This is a continuous function. Polynomials are continuous on minus infinity to infinity. And so this one is also continuous then on the closed interval 1 to 2. We're trying to use the intermediate value theorem here to show that a function has a root, or just in general that an equation has a solution. The intermediate value theorem is our tool. So to use the intermediate value theorem, the function must be continuous. And we've just established that because it's a polynomial, it's continuous everywhere. So we can use the intermediate value theorem on any interval. We just need to establish that 0 is indeed an intermediate value. So we will plug in the endpoints of the interval, p of 1 and p of 2. And in order for 0 to be an intermediate value, one of these numbers needs to be bigger than 0, and the other one needs to be less than 0. So let's plug in 1. If we plug in 1, 1 to the fourth minus 5 times 1 plus 3 is 1 minus 5 plus 3, which is negative 1, which is less than 0. And p of 2 is 2 to the fourth minus 5 times 2 plus 3, which is 16 minus 10 plus 3, which is 9. 6 plus 3, 9, which is bigger than 0. So 0 is an intermediate value for p of x on the interval from 1 to 2. And since p of x was continuous on that interval, we can conclude by the intermediate value theorem that there exists a number c in the interval from 1 to 2, between 1 and 2, such that p of c will equal to 0, will be equal to 0. And that's the same as saying the equation p of x equals 0, the equation we're given here, has a solution in the interval required, in the open interval from 1 to 2.